Okay, so here is our section of the course on advanced techniques for data analysis. To be very specific here, we're going to look at nonlinear regression. So nonlinear regression is an analytic technique for finding the curve of best fit. Up until now, we've been looking at lines of best fit. And a curve of best fit shares a lot of similar properties. It does have if you remember correlation coefficient, R, it's a measure of how closely data fits a linear regression. But in a curve of best fit, we use something called the coefficient of determination, R squared. And R squared is a measure that can apply to any kind of curve of best fit, whether it's a polynomial, an exponential, it applies to any. So R squared, in this red box here, it's defined as the variation in y explained by the variation in x divided by the total variation in y. So what's important to note is R squared does have a value like R to be between 0 and 1. And the closer it is to 1, the stronger the data fits the curve of best fit. And a 1 would represent a perfect curve, perfect fit. So I'm going to show you now an example of how to create an exponential regression or an exponential curve of best fit on the Excel spreadsheet. And if you forget what exponential functions look like, well, they're of this form. So you have some base raised to an exponent. Your x is now your variable exponent, and there's a coefficient, constant coefficient in front. Or if you're using e 2.71828, that would be your base raised to some exponent kx multiplied by a constant coefficient a. So here we are looking at an example. A laboratory monitors the growth of a bacterial culture by scanning it every hour and estimating the number of bacteria. The initial population is unknown. But I do have a table of values here, 1 through 7 in terms of time and number of hours, and the population for each of those hours are measured. I'm going to create an Excel plot of this. I'm going to go to Excel, and I'm going to type in the table of values. I already have it here, but I need you guys watching to type this yourselves. And I have time. Make sure you put hours to indicate the units of measurement here, and the population from 10 all the way to 475. And have them separated into 2 columns in Excel. Now to create my scatter plot, simply just highlight them. Highlight your 2 columns. Go to the Insert menu, and you're going to look for the chart that looks like a scatter plot. So insert scatter XY, and I'm going to select that scatter XY. Okay, and if you like, you can rename your title, population versus time, or specific bacteria, population versus time, and you could also proceed to add the axes label as well. And so axes titles, here we go. And my axis title in the horizontal will be time in hours, and my axis title in the vertical will be population. There we go. Okay, let me just make this a little bit bigger. And so there's our scatter plot. Now, as you can see on the scatter plot, a straight line may not necessarily be the best model because you're going to end up having points at the extreme ends far apart from or far away from the line of best fit. So it might be better to use a curve of best fit. Okay, so we're going to go and create a curve of best fit. And I'm going to see if I can get back to that. Insert. Trend line. There you go. So here, it's going to be under trend line. So I'm going to create a trend line. So look, it's sort of already defaults to line of best fit. Well, how do I get to this menu? You click on the plus sign on the top right corner. So trend line right here. Looks like a line of best fit, but you can notice if I do that, you're going to have points. The extreme ends of the points are going to be far away from that line. You might find that there's a better fit to the data, and you have different options to choose from. And I'm going to choose exponential. So if I click on exponential, You'll notice now I have a curve that has a better fit through more of my points. Not a perfect fit, but it's a better one than the line. Okay, so I'm going to click on that, and I want the equation of this trend line. And by the way, if you want to change it, you can just double click on it and you can change it to other ones. So you want polynomial, you can have logarithmic. Logarithm doesn't quite work, but we'll go back to exponential, and there you go. Now, the formatting of the trend line, this menu right here, will help you get the equation and the r squared value. So at the very bottom, you'd see here, display equation of the chart. So I can display the equation, and I can check mark the display the r squared value on the chart, and I get the r squared value as well. Okay, so now I have just done an exponential curve of best fit, and Excel has already calculated those values that I need. So I'm going to just go back to my page here, and I'm going to use the kind of rounded value. So the A was 5.7 if I round it, and my K value, let's go back to my Excel sheet, let's read the K value, 0.6569, so I'll round that to 0.66, and my R squared value was 0.995. So we have a really good fit here. It's close to 1. It's a really good fit for my exponential regression or my exponential curve of best fit. And if you want to just draw that as well here inside your notes, you can do something like that as well and show that curve of best fit. But sort of fit through most of the points there at the beginning. It sort of went like this toward the end, but that's what it is. And you can do the same thing on the handout with the other examples, going through the other types of curves of best fit. The next one would be polynomial. Polynomial regression, so you can have degree 2 or degree 3, and a power regression at the end as well. And I'm going to stop this video here.